Today we are going to cover how to now get equations of straight lines and work around straight lines and all their other conditions. Um, so to have an equation of a line, so basically, the equation of a line is just a set of points that satisfy a particular straight line. A set of points that satisfy a particular straight line. That's what we call that's what we are trying to study. Okay, so in that we need to get something called, for you to have a straight line you need only two things. You need two major things. You need the gradient m, and you need a point p. Godfrey, can you mute yourself for now? So for you to have a gradient, so if you have a straight line, we need just a gradient and a point. This is all you need for you to be able to derive the equation of a straight line. So first, if you don't have the gradients, go look for the gradient and find any points that belongs to that line and use it to find the gradients of the line. To do that, this is the equation that we generally use. There's a constant y that we don't touch. It doesn't change throughout. Y minus, let me do y1. Y1 changes. It's going to come. Y1 is going to be the y of the points that you choose, equals to m, which is the gradient, to multiply x minus x1. Yes, someone raised their hand. Yes, Godfrey, raise your hand.
Is it the same as the s and the y, s, y, s, y2, the x1?
Yes, it also comes from the point.
So, are they in the same formula?
Yeah, they are in the same formula. So the formula is this entire thing. So y minus y1 equals to m multiplying x minus x1. This is the entire equation. So that's the formula. When you are done, you make y the subject. Then at the end of the day, you have your equation of the line. So basically, if I give you a gradient, let's say a gradient to be 2, and I say there's a point on that line that is, let me do 3 comma 1. So to put that into the equation that we have, is going to be y. This y we don't touch it. All the y, this particular y that is not numbered, is never touched. You never touch it. Y minus y1. Y1 is going to be the y of the x of the point. It's going to be the y of the point. So the y of this point is 1. So it's going to be 1 equals to the other one, which is the gradient. The gradient is m. So you write 2 to multiply x minus x1. x1 is coming from the point. So it's going to be 3. This x and y, we never touch them, we never clean them, we never clear them out of the distance. We keep them like that. When you are done, you try to make y1 y the subject. So let me make y the subject. Then you are going to have y minus 1 equals to, I will expand here, become 2x minus 6. Then y is equal to, I'll bring negative 1 to the other side, become 2x minus 6 plus 1. Then your y equals to 2x minus 5, because these are constant, so put them together, you get minus 5. And this is the equation of the entire line that you are supposed to get. So make y the subject. Y is equal to something that gives you the equation of the line. So at the end of the day, the general equation of the line, when you make everything the subject, you have something, y is equal to mx plus c, where c is the constant. This is what you finally get as equation of the line generally. Are we good?
Yes, sir.
Okay. Sure.
So,
Yes. To find the equation of a line, we say use the formula that you use, general formula that you use. And the y, we don't touch this y, but the y1 and the x1, they are going to come from the point. The point has coordinates x1 y1 basically. So these are going to come from the point, or let me do xp yp, so that it's as if it comes from the point. So yeah, someone raise their hand.
So why are you not using the y? Is the why are we not using the y and the s? Only the yp and the xp.
The y and the s are going to be for any other point. They are going to stay there to satisfy any other points that will form on that line. Right now we are just finding the equation of the line, and in the equation of the line, when you are finding the equation of the line, you are supposed to finally have it in this form: y is equal to mx plus c, where c is a constant. So we need to, in your equation of a line, we need to see some x and we need to see some y. So when we are starting from here to move towards this side, we need to keep this y and s so that we finally have a form like this. And this y and s is going to be in place of any other point that will form on that line. Because when you see a straight line, a straight line is a composition of many points. This point one, joined by point two, point three, point four, point, many of them come together to actually give you a straight line. So a straight line has many points. So for each of the point has s and y, but we are just picking one of them. We are going to take only one of them out. Let's say sp, yp, and use it to generalize a particular equation for all of them. So this y and s is actually going to represent all x and y on that point. For that matter, we don't touch it. We keep it for the equation of the line. It's when we are testing for individual points into this equation that we now replace them. But if you are building the equation, you go into this form, you don't touch this y and you don't touch this x, but you only use the yp and the sp. Are we okay? Yes.
So
Yeah, I can hear you.
so if you give a number, you use that number to replace it.
Yes.
If you use if you give us a number,
Okay. So what will happen is that we need to first understand how to
we
draw the
only use the number to
equation.
replace the y x.
Yeah, we'll do another. That's another concept. How to now test that a point belongs to a particular line. That's a different thing. But right now we are learning how to build the equation first. Okay.
Bro.
So right now we need the equation first. After building the equation, before we now test if a point belongs to that particular line. Sure. So first, I say to find the equation of a line, we need two things. You need a gradient and you need a point on that line. So that point on the line, I'm calling it SP and YP. And then that's when you start the equation from this side so that you can finally have a form. Then from here, you do mathematically, you make y the subject, then you finally get something like this. This is where we are finally getting to, where y is equal to ms plus c. M is the gradient and c is a constant that will come out from the mathematics that we'll do generally.
Yes.
So, and I give an example that if that's the case, then if you have a gradient m, for example, equals to -1, and I have a point P which is having 2 comma -2 as a point, and then I'm to find the equation of a line for this one. First, you need to start from this general equation first. It's going to be y minus yp. Y of the p, or y of the point, is -2. So -2. This negative is different from the -2 from this. Keep that in mind. The yp is already negative on its own, so you need to keep that in mind. Equals to m. M is the gradient. So the gradient here is -1, which is multiplying x minus x. This s and y, we don't change them. We don't take them away. So x minus xp. Sp is 2. Is 2 itself. So this negative is always there. Don't confuse it with the other thing. Now the target, after putting this equation, the target is now to make y the subject. So this will give me y plus 2 equals to -s plus 2, because I'm now expanding. After you expand, you have y is equal to -x plus 2 minus 2, because this -2 will move from the other side. And at the end of the day, you have y equals to -x plus 0. And 0 is the constant in this case. If it is 0, we don't even care. We just do y is equal to x when it is 0. But c, so it's like y equals to mx plus c, where m is negative 1 and negative 1 is here. So it's negative 1 times x, but because it's negative 1, we just do negative x in simple terms. That's why it's like that. So finally, we need to finally get to a form like this: y equals to ms plus c. The coefficient of the x is the number that stands against the x. Finally, is the gradient of the line. That's one way of deriving the gradient from the equation of the line. Okay, so when we actually go tricker and then they give us 2 points, let's say they give us these 2 points and we are asked to find the equation of the line that a and b belongs to. We are asked to find the equation of a line that a and b belongs to. The thing is, for you to have equation of a line, we need a gradient m and a point p. A point p is any of them. You can pick any of them. In this case, I'm going to pick the a. So my a is going to be that point 1, 2. You need to pick a point that is among any of the one of AB. But here, we don't have the gradient yet, but we have learned how to do gradient already. So from these 2 points, the 2 points are actually given to you so that you can use it to find the gradient. That's the trick it. So now once you calculate it and have your gradient, then you can use the gradient and any one of the points. You can use B, you can use A, any of the points to work around it. So for the gradient of this line, we know that gradient is equal to change in y over change in x. I'm doing 6 minus 2 all over 4 minus 1. That will give me 4 over 3. Is that correct? Yeah. So m is equal to 4 over 3. Now I have my m now, so I can choose any of the point to get the equation. So what I'm going to do is that I will use a to build the equation of the line, and I'll use b to build the equation of the line to see if we finally get to the same answer for each case. So for the first case, I'm going to use point A and then point B. Then we see if we actually arrive at the same equation of the line. So let me divide this into 2. Let me use point A here, which is 1 comma 2. So we know generally the equation of the line is y minus yp equals to m multiplying x minus xp. This is what we need. This is our starting point if you want to find equation of the line. Now we are moving towards the final point. So to get to that final point, we need to begin to replace the values. This first y, we don't change it, we keep it. But the yp is from the point, so it's going to be 2 in this case equals to m. M is what I calculated. I think that's 4 over 3. So I have 4 over 3 to multiply x minus xp. Sp is 1. The s of the point is 1. So in this case, I now have y minus 2 equals to, I will expand this. This 4 over 3 will expand the bracket. We have 4 over 3 multiplying x minus 4 over 3. Then let me clean this. Then we have to move the 2 from the y so that we can have only y at the other side. So y equals to, let's make y the subject. So we'll move this one to the other side. So let me write what is already there: 4 over 3 x minus 4 over 3. They were here, and then negative 2 become plus 2. And now this is a constant. These two are now constant, so we need to group them together. That will give you y is equal to 4 over 3 x. This and this will give me plus 2 over 3. So 6 minus 4, that's 2, yeah, 2 over 3. So at the end of the day, this is the equation of the line. We have it y in the form y equals to mx plus c, where c is the 2 over 3, the x is the x, 4 over 3 is the gradient of the line. So this is using the point A. We can do the same thing using point B to see if we arrive at the same thing. So here I'm going to use the point B among the two. You can either use A or B, but I'm just, for learning purpose, I'm doing both. Point B. For point B, I'm going to have y minus yp, like this is the starting point, equals to m multiplying x minus xp. So we have y minus 6. In this case, the y is 6 equals to m is 4 over 3 x minus xp, s of the point, which is 4 in this case. Then we have y minus 6 equals to 4 over 3x minus, this will multiply it will be 16 over 3. At the end of the day, we now need to make the y the subject. So we'll move the negative c to the other side. Then have minus 16 over 3 plus 6. Then what happens? We need to now solve. So y is equal to 4 over 3 x. Now it's left this and this, this and this. If you solve this, put this in your calculator, you are going to have 2 over 3 as well. 2 over 3 as well. So you can see that using point A or point B, we still arrive at the same thing like this one. So once you have the 2 points and you're able to find the gradient, just go ahead and use one of the points. Mostly use the simpler points that can work for you. Then use it to find the equation of the line. Are we good?
Yes, sir.
Is there one person in the class? Are we good?
Yes, sir.
Okay, sure. So now that's the equation. So we solved this one already. I'm going to give this one, definitely that's what we used to do. So this is going to be for Kennedy.
You don't.
Nobu, are you saying something?
Nothing, sir.
Please,
I'm okay.
Alice, are you saying something?
Yes, please. I was saying I have network issues.
I have network issues. Wow. You have network. Oh, sorry.
No, I said me. Yes, please.
Okay, sorry. Everything will be fine. But we are recording it, so catch up anytime that you miss a class. Are we okay?
Okay, sir.
So let me give that. This one was for Kennedy. Noble, you are going
Sir.
to have this pair of points. So Kennedy, you can start yours as you do as usual. You take me through how you get your answers. Alice, can you give me a pair of points? Can you give me a point?
Okay. 2 negative 2.
Really?
I've used negative 2 already.
Three.
Okay. Give me another one.
4 negative 3.
No, they shouldn't be the same.
4 4.
Oh, okay, 4 4. Yeah. So when you are ready, you let me know. Kennedy, let's go.
So, sir, our gradient is negative 5 minus 5
Negative 5
minus 5 all over 2 minus negative 3, which is 2 plus 3.
Okay, so this
So
will
we
be
have
negative 10
negative
over
10 all over 2 plus 3, which is 5.
5.
So our gradient is negative 2.
Okay, sure. Sharp.
Then we use the formula y minus y1 is equal to m into bracket x minus x1.
Okay.
So when we input it, we have y minus 5 is equal to
Which point are you using? We
negative
don't know.
2.
Which point are you using?
I'm using the point P.
Okay, okay.
So it's equal to negative 2 to bracket x plus 3.
Okay, sure.
So if you expand, you have y minus 5 is equal to negative 2x minus 6.
Minus 6. Okay.
So you send the negative 5 to the other side. So you have y is equal to negative 2x minus 6 plus 5.
This is gradient.
So our
Okay.
final answer is y is equal to negative 2x minus 1.
Okay. Yeah. Noble, are you ready?
Yes, sir.
Okay, sure. Let me clean your side too. Noble, we can start.
So my gradient, which is small m,
Mm-hmm.
is equal to y2 minus y1 all over
Yeah.
x2 minus
Give me the
x1.
values.
So it's 4 minus 2,
Mm-hmm. 4 minus.
2,
Are you sure?
4, y2. So sorry, 4 minus negative 3,
All over.
4 minus 2,
Okay. Then we have
which is
4 plus 3.
6, yes, 4 plus 7, yes, over 2, which is 7 over 2.
Okay, so let's continue. So which point are you using?
So I'm using the first point.
2 negative 3.
Yes, sir.
Okay.
All right, uh, so the gradient is y minus y1.
The gradient of the equation.
Sorry, the equation of the line
Okay, sure.
is
Equals
equal to
to.
m open bracket x minus x1
Okay.
and y is minus negative 3
Okay.
equal to 7 over 2 open bracket, yeah, sorry, open bracket x minus 2,
Okay, sure.
which is y plus 3
Mm-hmm.
is equal to 7 over 2x minus 14 over 2,
That will be what?
which is 7.
Okay, let's go like that. We have y
Yes, which
plus
is
3 over 7 over 2 minus 7. Okay, let's
yes.
go.
Then y is equal to, we're making y the subject. So
Okay, this is
2
first.
over 7, so I didn't bring it. Yeah, 2 over 7x, 2 over 7x.
Where is the 2 over 7 coming from?
So sorry, 7 over 2. What the hell am I doing?
X, right? Minus 7.
Yes, minus 3.
Okay,
Then y is equal to 7 over 2 x minus 10. That is the
okay.
answer.
Yeah. So finally, this is the answer. Okay, so you should take your time, okay?
Yes, sir.
Yeah, things are easy. So if they are easy like if the things are easy like this, if you are not careful, you will get stranded. Okay, so let me now give you another one each, right? So Kennedy, you use the point P 1 negative 1, and you use the theta. You use theta to be 30 degrees. Um,
Yes, sir.
Noble, you have point 2 comma negative 1, and you use theta to be how do you call it? Hmm. I'm looking at something for you. Um. You don't have the calculator, right?
Yes, sir.
Oh, you don't have calculator, so that would be a problem. Let me just give you M straight.
I think okay, it's okay.
M equals to negative 3. This one, I just want
Just
the,
have to solve.
yes, I just want the final. No, I think Kennedy's phone. I need the steps.
For mine, you need a final answer.
Yes.
Said just to be sure.
Uh-huh.
My question is P
Yeah.
bracket open 2 -1.
Negative 1. Ingredient is
All
negative
right, sir.
3.
Okay, so I'm done. The final answer.
Okay. Yes, Noble.
So y is equal to -3x plus 5.
Plus 5. Let me see. This is negative 1. We'll go to the other side. Negative 1 will go to the left one, positive 1. And negative 3 times negative 2, that will give me negative 6.
So -3 times -2.
Yes, that will be 6.
Yes, 6. Positive 6.
Yeah. Okay, yeah, this is correct.
All right.
Kennedy, are you
So
done?
please give me one.
So
Okay.
I'm almost done.
Okay. Alice, so you take point 1, 3, and the gradient M is equal to 5.
So can we also solve?
Yeah, you can solve it. So that we confirm if she's right or not.
Sir, I'm
Yes.
done.
Okay, so if you are done, let's
Sir,
proceed.
by my question, I was getting said answers.
Yeah, if you said
Say.
What is it?
yes,
So we'll first have to find the gradient. So we use theta is equal to tan inverse of gradient or tan inverse of m.
okay,
So we'll have 30 degrees is equal to tan inverse of m. Then when we make m the subject, we have m is equal to tan 30, and tan 30 is equal to √3/3.
root 3 over 3. Yeah, so
Yes, sir.
yeah, it's okay. It's okay. So you finally get to an
So
equation. Right? What's your final equation?
y is equal to √3/3
X.
minus, yes, minus a fraction with numerator 3 minus √3, and the denominator is 3. But when I
Okay,
turned it to decimal form, I had y is equal to 0.58x.
I'm coming. You say y is equal to 0.58x
58x
minus
minus 1.58.
58. Okay, okay. But this would have been correct. But I just wanted to test the concepts, and it's good that you still remember that. And you'll be able to
Okay.
connect all of them. Very good. I know Noble will have done it because he doesn't have calculator. Alice, are we ready? Um, Kennedy, well done. Eh?
Please,
Yes.
I thought the points are going to be two.
Ah, actually, what you needed the point, the 2.4, I've gotten it. I've given it to you already, which is M. So you should have just worked with the M.
Should I give you the answer?
Yeah, let me see what you have, Noble.
Y is equal to 5x minus 2.
Minus 2. I will confirm. Alice, so don't worry. When you watch the video, you will be able to understand what we are doing. Okay. Is she gone?
So I got the same answer.
Okay, sure. Is Alice gone?
No, please.
Okay, so when you watch the video, you'll be able to catch up.